My name is Bill McAnally. I'm from Iowa Central Community College over in Fort Dodge, and I think this is about out of the 17 years, about the 15th time that I think I've been here. So this is always one of my favorite places to come during the school year. It's a good way to get away on a Saturday and enjoy it. I wish it was a little bit better weather, but just to give you a little background, I was a building contractor for 15 years. I really specialized in energy efficient construction when it was not popular whatsoever. Back in the late 70s, and then I was a carpentry instructor at Iowa Central for 18 years, and I've just been demoted or promoted, however you want to take it, to a department chair level. So I don't get to do any teaching really, except maybe some building science, but we get to do a lot of presentations and building investigations, especially building failures. We're doing some things with Iowa State University currently, Department of Economic Development, and some utility companies on rebuilding Iowa. Some of the things I toured, I spent some time with Iowa State University and Linda Bigley from Linn County down in Extension, and toured what was going on in Cedar Rapids. And you know, it's being up in Fort Dodge. You see it on TV. You know, people from out of state call me, well, is that really as bad as it looks? You know, oh, well, I'm sure it's not until you really go down there. You don't really realize the devastation that there was. And probably the hardest thing for all of us that were going through the buildings, because we had a friend that was actually owned a house there, was just seeing, you know, the emotion kind of taking over. And so that's one thing that we're trying to get. I wish things were moving a lot faster. Is the hard part of seeing people that want to get back to their regular way of living and get back into that neighborhood and get back to being with their friends and letting emotions taking over and trying to maybe remodel a house that really isn't worth putting any time into at all. It was really devastating how much mold issues there were and structural issues. But you know, and if you have questions, you know, we'll cover them at the end. So one thing that we have a positive thing at Iowa Central was we just started the Green Building Institute, and we're kind of using that as a clearinghouse for information, or if people have questions, that we can go out and possibly help or maybe demonstrate the things that have worked for us in the past, things that haven't worked for us in the past on projects. And in the carpentry program, what they have been doing in the past was energy efficient housing. This particular one was built a few years ago. Zero-step entry. We tried to make it as compliant with universal design as we possibly could. We absolutely see no reason why every house in Iowa isn't built to universal design and made energy efficient. It's kind of funny that we've been doing this. I've been doing energy efficient construction since, I think, 1978. Been laughed at. You know, why are you doing that stupid stuff? Nobody will ever use that product. Your students will never get hired. You're teaching them things that they don't need to know. And the nicest thing right now is that I told you so. I just love that now when all of a sudden now we need your students because they know building science. They know energy efficiency. They know green building, and I just love that now. I love it when gas prices go up because it means really nothing to us that have an energy efficient home. If it goes up 30%, big deal, $8. It really doesn't mean anything in a good quality home. But homes like this is a poor design. You know, we need to get back to making simple designs. We need to get away from this, you know, look, the curb appeal. You know, we should be looking at practicality. This is not a practical house. It's a very efficient house. You'll never see the windows open at all because it has a ventilation system that you know, we put high performance filters in it, so there's always clean, fresh air coming in, stale air going out. They can control their relative humidity. They can control their indoor environment. But look at that roof. That roof and the design was strictly for curb appeal. You know, we need to get back to the simple, I know maybe not as pretty, but simple, lower pitch, because why do we have pitch roofs like that? Can anybody tell me why we have steep pitches on houses in Iowa? It looks pretty, the house looks bigger, and that's it. You pay about another $10,000, $15,000, and why do we always have water coming down in all these valleys and causing problems? It's just a lot of maintenance down the road. I was just in Walla Walla, I just love saying that, Walla Walla, Washington, to Walla Walla Community College, because they have a kind of a artificial economy there. They have 160 wineries around Walla Walla now. The ground is perfect for raising grapes. And as we're driving through the town of Wall to Wall. It's a high desert. And so it gets warm, cool at nights, and dry. As I'm driving through there, the only houses that had steep pitches were the new ones. All the old ones had nice, flatter pitch. And what color do you think the shingles were in a hot climate? Nice, light-colored shingles. Why do we have to have dark shingles? Everybody talks about it. We need radiant barriers. We need this, to keep the heat. If you just went to a lighter shingle, but if I shingled that with white shingles, you think I'd be able to sell that house? No. So a lot of the presentation that I want to go over is completely, it's in our mindsets. We need to start changing our mindsets to realize that if you're going to make an investment, invest in building it sustainable, building it energy efficient, as maintenance-free as you possibly can, and make it universal design. If you have 0 steps, if you have 3-foot doors, 4-foot hallways, you put your receptacles up higher, you put a little receptacle behind the toilet, so in case you ever do blow a hip, you don't want to, that you can put an electric toilet seat that raises and lowers you down. All these things are very small features to put into a house, because then that gives that house a life, that you can go from multiple owner to multiple owner, instead of one that's built specifically for somebody that's built cheap right up front. Because when we look at affordable housing, usually when you look at affordable housing, it's affordable only for your mortgage payment. That's it. It was built cheap right up front, get you in the door, you're in there, all of a sudden you're in there, my God, when January rolls around, I can't afford to live here anymore. And maintenance, all these little issues. They didn't insulate the basement. Well, it wasn't enforced. So we have to get back and kind of change our mindset. One of the things we've used in the past is we've been building residence halls on campus. Right now we're starting the 15th residence hall like this. The neat thing about it is when you build projects like this, you can try all kinds of different methods, every type of insulation you could possibly think of, different framing methods. We have a perfect laboratory. We can go around and look with infrared cameras, moisture sensors, temperature sensors, and see what's actually working. And what we found out just in the last few months, in '96 when we started putting these buildings up, we didn't have any real specific proper ways to put in windows. Now we're seeing from 1996 a contractor on campus put some windows in. The windows are rotting out. The wood is rotting out because they were flashed incorrectly. They were flashed to industry standards at that time, but we've learned that now the way we're putting in windows is the correct way, and we wouldn't be having these maintenance issues if we'd have known things 10 years ago. So we like to use these also as kind of a lab experiment. And if we're going to learn anything, we need to look at the past. This is a house that we were called into last year. A lumber yard in town called and said, can you come over and take a look at this house? They tore off the drywall, and there's a little bit of moisture. Now, this is the old asphalt impregnated buffalo board, and you can tell the original color is right up there. This whole corner, all those dark spots, there's so much moisture in that insulation board because it does suck in moisture. It's saturated. The moisture sensor sits right down here. When you poked into the wood, water came out. Okay, the first indicator that this house had an initial failure going on was it had vinyl siding on it. When I look at a house that's built an old, like say from the 50s or 60s on back, if it has vinyl siding on it, why do we put vinyl siding on a house of that age? What are we covering up? All the problems. They're still there. It just looks pretty, but they're still there. So we have to learn what of the things we've done wrong. Why don't we get rid of the moisture that's inside this house? When we told the homeowner what they had to do, they had no ventilation in the house, no vent for the oven. They had a crawl space underneath that was not sealed, so all the moisture coming from the ground. The moisture couldn't get out. The only place it could go was inside the walls, hit a cool surface, condense, and that building is failing. So when you go to a big box lumber yard, what do they tell you to do? It'll dry out, no problem. Go ahead and throw the insulation in, re-drywall it, and go ahead and paint. We told them exactly what they needed to do. Do it right or do it cheap. Did it cheap? It's exactly the same way right now inside that wall, just like this. Hard to tell how much mold is growing inside those walls. So we need to be looking at what we've done in the past and learn what's right. This is a house from Cedar Rapids that this person immediately took siding, drywall, everything off that house. Will they be able to repair this house, do you think? Sure. Everything's nice and dried out. But the houses around it, like the one next door, they left it, shut the door, and you can't even hardly get within 10 feet of that house getting knocked over from the smell of the mold. This house was allowed to dry. In fact, it was probably just like this when they framed it. You know, when we build houses, we frame it, it gets rained on, sure. But this was allowed to completely dry. They took all the wet material out, and they could come back, because that's about 6 inches higher than where the water table was, right there on that house. They learned. They did basically all they did, I think, was get on the internet and look and just rebuild after flooding. And all the information you possibly need is just open it up and let it dry. Most of them, and I can see that. Most of the people are just fed up with it, shut the door, walked away. Yes. Now, there you go. Good point. There was a lot of stuff going on, and then you look at the color of the tag, and there's all... You weren't allowed back in to do anything until they... Yeah, because I had a friend that spent a week over there tagging, and his pictures are just, they almost make you cry. But at least this house, can be redone. This is also inside one of the houses. All mold. Now, can you test for mold? Can you test for mold? Does anybody know how they test for mold? You can open up, really the only test, especially if you go to the Iowa Department of Public Health, ask them, how do you test for mold? Because the only real test is your nose. If you can smell it, it's there. Any of these test kits for mold, once you open it and shut it, it's going to test positive. Doesn't matter where you open it. We can go out in the middle of a football field, nice breezy night, just go like that, and you send it in, and there's mold. So don't waste your money, because every one of them will test positive. I don't think they've ever seen a Petri dish come back that was negative, unless they went real fast. I don't know how they're ever going to do it. And so the neat thing, too, that people need to know is that no matter what color it is, it depends on your particular sensitivities. You can have black, stachybotrys, toxic mold, and you may not have any sensitivities to it. You may have some little green or yellow one, and you have sensitivities to it. There's 2.5 million species of mold out there. Like 1 million of them are considered toxic. So it just depends on your sensitivities. But the thing is, you have to get rid of it. You have to wash it all, clean it, get rid of it, and then get rid of the problem, which is almost always just moisture, just water. This isn't the way to handle our housings. Just to go ahead, okay, tear it down, get rid of it. And the neat thing about this house is that was a precursor to vinyl. Remember that asphalt, kind of fake brick-looking stuff? Who would believe that actually was brick anyway? I mean, really. So when we start with the foundation, and especially with new houses, and I always like it when people say, well, the ground's going to keep it warm. Well, how much your basement actually is in the ground? And then what's the temperature of that soil? If you're looking at warm, you're looking at 52, 54 degrees, that's maybe underneath the basement slab, but everything else is cooler in the winter as you come up. You never needed insulation before. Why did I need insulation? Well, you didn't really care about utility bills back then. You are supposed to insulate that basement according to the Model Energy Code of Iowa. In our area, you have to have at least R10, which is resistance to heat flow, which is equivalent to about 2 inches of like blue, pink, green foam, not the white foam, but the blue foam. If you have 2 inches of that, that's about what you need to insulate to. And then you actually meet the minimum. And remember, building codes are minimums. They're not any standard up here that you can hope to achieve someday. That's a D. That's a D minus. What do you recommend under a slab? Under a slab? The only reason, if you're going to have radiant floor heat, the question was, what do you recommend underneath a slab? If you're going to use radiant floor heat, you'd have 2 inches of extruded polystyrene. We always put 1 inch. Has nothing to do with energy. The reason that we put 1 inch foam is there's a consistent vapor retarder underneath it to keep, radon and water. But the